Welcome to video 5 of Gamer to Game Developer Series 1, and in this video we'll be implementing our spawn system. So we have three major objectives in this video. The first is to set up a spawn system for our player, so we'll reconfigure our player, we'll set up some spawn points, and we'll write a spawn script. Then we'll reconfigure our player for multiplayer. So this will involve editing a whole bunch of Unity scripts and our own scripts, and we'll also write a new script called a movement update script to keep the movement of our player up to date across the network. And the last objective is quite a simple one. It'll be about locking and unlocking the mouse cursor. So when the player is using a menu and they have it open, then the mouse cursor should unlock so they can see the mouse cursor. So I'll just talk a bit about the spawn system. So when the player connects to a server, they'll be given the option to join the red team or join the blue team. So if, for example, the player chooses to join the red team, then the spawn script will network.instantiate that red team, well, a red team player prefab for the player. Now, where will it instantiate it? That'll depend on the spawn points. So what we'll have is a whole bunch of spawn points on our level. Some will be for the blue team, some will be for the red team. We'll give it a tag. So we'll give our spawn points a tag like spawn blue team or spawn red team. Then the spawn script, when it's about to instantiate the player, it'll store a reference, it'll do a find, it'll find each spawn red team, if it's a red team player to spawn, and it'll place a reference to each one inside an array. Then it'll randomly choose one of those from the array and then instantiate the player at that position or the same position as that spawn point, and also at the same rotation. So we move on to our first step, which is to set up our team player prefabs. I've jumped over to Unity now, and we'll create two new prefabs. So create prefab, this one will be player red, and the second one will be player blue. I'll then create two new materials. So the first one, create material red, so it'll be the color red. I'll change the shader type to specular, and I'll change the main color to a deep red, so R255, G, the green, to 15, and I'll set blue to 15. That looks good. And I'll change the specular color to full white, and that looks about right. We can also change the shininess, but we can do that later. So I'll create another material now and call this one blue. Change the shader to specular. I'll change the main color to a deep blue as well. We'll set the red to 55, the green to 55, and that looks about right. Change the specular color to full white, and that looks good. So now let's drag our player prefab into the hierarchy. I'll reset its Z position to 0, so it's in the middle. That's good, we have it right there. Next, I'll change the tag. So I'll create the player red first. I'll add a new tag, and I'll create both tags at the same time while I'm at it. So I'll say for element 1, I'll say red team, and for the other tag I'll say blue team. Alright, and now I'll assign this first tag, I'll assign red team, and I'll change its graphics. So I'll just simply drag the red material onto the yellow to replace it, and we have our red player set up. So I'll drag this prefab from the hierarchy onto the empty player red prefab, and now we can edit the same player. We can now change the tag to blue team. We'll change the material, so I'll just simply pick blue and drag this onto the empty player blue prefab and delete the original from the hierarchy panel. And if we drag them in, I'll move the blue team player out of the way, drag the red one in as well, and we can see that they've been set up, and most importantly their tags are correctly set up as well. So I'll delete them, And we've completed this step. I'll just save the scene and we can move on to setting up our spawn locations. We've reached step 2 of 3, which is to set up our spawn points. Let's put in an empty game object. So go to game object, create empty, and I'll reset its position. So reset position. I'll set the Y to say 0.5 because our player will be instantiated at the position of, this is going to be our spawn point, and if we put it too low they'll be instantiated in the ground and fall through the plane. And I'll give this one a name of, say, spawn blue, and I'll assign a tag as well. So go over to tag, add a new tag. So I'll call this spawn blue team, and also make the other tag for the red team spawn points. So spawn red team, and now I'll assign it to our game object. So I'll go from untag to spawn blue team. Oh, and I probably forgot to hit enter. So spawn blue. Okay, so that's our first one. And for our blues, so what we're going to have is we'll just place 3 spawn blues, we'll place 3 spawn reds in parallel. So I'll just set the Z to -10. So I'll zoom out some more. Now I'll just duplicate it. So Control D, and I'll change this one's X position to 3. I'll duplicate it again and change this one's X position to 6. So we can see that they are in a line. So I'll create now another empty game object, create empty, and I'll call this one spawn group blue, and I'll have it have the position, so I'll press enter to accept that name, and I'll place it where the middle in the center of our spawn blues. So 603, yes, it is in the center, and all we're going to do is just select all these spawn blues and drop them inside this. So it just keeps our hierarchy panel tidy. Actually, there's no real other purpose, it just makes it easier to manipulate. So for the red team spawn points, I can actually just duplicate this group. So Control D, and I can just rename this spawn group red. And I'll change the Z position to 10. And I'll go through and change each one. So instead of spawn blue, it's now spawn red. And the new tag to spawn red team. And do that for the other ones as well. So spawn red. Change the tag. And once again, spawn red. And change the tag. Alright, and I'll just quickly check them, that I've put them correctly. Their positions, how are they? Yep. Oh, and you'll notice, by the way, that the position, it suddenly looks different, like it's a -3 compared to, compared to what we might have originally had, was we had a 6, 3, and 0. And the only reason why we don't see that anymore, like a 6 there, is because it's -3 relative to the parent game object. So that's all. Alright, so we've just set up our spawn points. So we can move on to our next step, which is to actually write the spawn script. Alright, we've moved on to our third step in Objective 1, which is to write that spawn script. We need to make a new script called the spawn script. So go to our scripts folder, create C# script, spawn script, and open it up in mono develop. and we've been taken to it. So as usual, let's put in a summary. So this script is attached. We're going to create so I'll just type that up. This script is attached to the spawn manager. So we're going to create an empty game object called the spawn manager to actually hold the script, and it allows the player to spawn into the multiplayer game. So to spawn into the multiplayer game. Alright, so that was a nice simple one. Now as usual, I'll get a variable start and end line. So I'm just borrowing this from the Fire Blaster script. So copy, paste that in, put a few lines and do the same thing. Alright, and now I'll type in our comment for our first variable. So this variable is used to determine if the player needs to spawn into the game. So needs to spawn into the game. And what is this variable? Private bool just connected. I do that a lot, putting a capital O. Just connected to server, and is equal to false. Now we continue. We'll add a new comment as well. Used to determine, so our next variables are used to determine which team the player is on. Which team the player is on. And so public bool, am I on the red team, is equal to false. And the other one, public bool, am I on the blue team, is equal to false. And then we'll have a bunch more variables. This will be to define the join team window. So used to define the join team window. And this window is, it just simply has, for now it simply has two buttons which the player can click on. The player can click to join the red team or join the blue team. So now private rect join team rect private string join team window title message. No, I don't need to write message, just join team window title should be sufficient. It's long enough. And I'll call that title team selection. Next variable, private int join team window width, and I'll set that to equal 330. Private int join team window height, and that'll be 100. Private int join team left indent, private int join team top indent, and then private int button height is equal to 40. Alright, so that's our variables for now. I'll just say what we've done so far. And we can move on to making our own function. So underneath void update, I'll just create a whole lot more space. And I'll type here void, so a new function, join team window, and in brackets int window ID. And as usual, the parentheses. So our join team window, it has two buttons in it. So the join red team button and the join blue team button. So we'll just define them right now. So a first comment is, if the player clicks on the join red team button, so on the join red team button, then assign them to the red team and spawn them into the game. And the code for that is, if GUI layout dot button, the text on this button is join red team, and the height is GUI layout dot height button height. Close all the brackets. Then within the if statement, when the player clicks on this button, we set MI on the red team to true. No, not to MI on the red team, to true. And just connected to server is false, because now they've actually joined the team. Okay, and we do the same thing for the blue team player. So I can actually just copy all this code, put a space, paste it in. Now just change the wording, join blue team button, then assign them to the blue team and spawn them into the game. If GUI layout dot button join blue team, yep, that's alright. Then we change the variable MI on the blue team to true, and just connected to server is false. Okay, I can save what we've done so far, and we'll now put in the onGUI function. So void onGUI, and within its parentheses we'll put in the comment, if the player has just connected to the server, then draw the join team window. So what does that code look like? Let me scroll down a bit. Alright, so that code will look like, if just connected, just connected to server is true, then we draw that join team window, which we have just above here. So we define the left indent, so join team left indent is equal to screen dot width divided by 2 minus join team window width divided by 2. And we do the same for the top indent. Join team top indent is equal to screen dot height divided by 2 minus join team window height. And it looks like I probably have not spelled something correctly because I don't see it in there. So let's go up and see what has happened. Join, yeah, I said joint team window height. No, that's join team window height. So I'll save that. Now go back down here and just rewrite that. Join team window height divided by 2. And then we do join team rect. So now we define the rect is equal to a new rect. And what's the left of that rect? It is join team left indent. Then for the top, join team top indent. Then I'll put the width, so I'll just bring that down to the next line. Join team window width, and then a comma, join team for the height, join team window height. and close that. Okay, we've defined the rect. Now we actually draw it. So join team rect is equal to GUI layout and not a GUI layout, sorry. It's no, yeah, it is GUI layout. Sorry, just confused myself for a moment. Dot window, and within the brackets the int ID. So I just put here 0 because it won't show at the same time as the main window, so I don't need to worry about that, a possible conflict. Join team rect and join team window, the function to run. There we go, that's it. And finally, what should be written at the top of the window, I'll just bring it down to the next line and say join team window title, and close that and put the semicolon. So our code is done so far. We can try it. It's not complete. We haven't completed our spawn script just yet, but we can actually connect. I mean, we can actually set up a game and just see what happens. So we jump over to Unity and we now create an empty game object. So game object create empty and rename this to spawn manager. And to this spawn manager we will attach our new script. So component scripts, we attach the spawn script. You can see our two public variables there, but anyhow, what we need to do is now build and run. So we go and do file, build and run. Start one of the games. We can set up a server in the meantime. So set up a server. Alright. Now connect to the server. And we don't see anything because I've forgotten something for sure. So we go back to our script. I've definitely forgotten something. And if you look, we need this condition just connected to server to be true in order for that window to be drawn. But we don't set it to true anywhere. So that means we're missing a function, and that function is void. I'll place it up here just above it after the update function because it's not much we'll write into it. Void on connected to server, and within that function we'll simply say just connected to server is true. Alright, and I'll save the script, head back to Unity, do a file, build and run again. Hit play, set up a server. Alright, and go back, connect, and it's working now. So I just simply made a silly mistake. I'd forgotten to put void on connected to server, and that was a Unity. So I'll just go back to the script there. This is a Unity function. This is not something that we've made up. And all it is that when it runs on the client's end and when they connect to the server, it simply runs whatever code has been placed in it. So back here, we can choose the red team or the blue team. If we click, I think just the, it just disappears, that's all. Because now we have, when we clicked on a button, we set just connected to server is false. And we are actually assigned to a team as well. And when it's false, this window simply doesn't draw. But now we need to add a lot more code. So we've gone that far. Now we need to add more code so that we can actually spawn the player into the game. So I'll go back to Unity, stop playing that, and close this down, and head back. I'll save it, and head back to MonoDevelop. And let's continue writing some code. So we'll set up two new functions. The first one is void spawn red team player, and within this I'll put in the comment. The first thing we're going to do is find all those red team spawn points. So find all red spawn points and place a reference to them in the array, which we're going to define in a moment, red spawn points. And before we go much further, I should add some new variables. I forgot to do that, so let's just scroll back up to our variables area and add the following new variables. So a new comment, the player prefabs are connected to these in the inspector, and we'll just have here public transform red team player, and we'll just simply attach our red team player prefab to that in the inspector. Public transform blue team player, private int red team group is equal to 0, private int blue team group is equal to 1. The next comment, so used to capture spawn points, or reference to them anyhow, private game object, and note now I'll put 2 square brackets, so square and that. That's how we define an array. So this variable is an array. Red spawn, so an array can accept instead of just one piece of information, it'll hold more than one piece. So in this case it could be like there's one piece of information in it, then you can imagine like there's a comma, then a second piece, then another comma, and another piece of info. So that's the idea. So red spawn points, instead of us having to create a new variable for each and every single piece of data. Red spawn points, and private game object, again the square brackets, blue spawn points. Okay, so we've set up our variables. We can save that and go back to writing up our spawn red team player function. So down here I'll type red spawn points is equal to game object dot find game objects with the tag, and we had named that tag spawn red team, and I can just check that by going to Unity. Spawn red team, yes, it is that. So I'll go back. So now that we've got a reference to them, we'll randomly select one of those. So randomly select one of those spawn points. Randomly select one of those spawn points. So that'll be game object random red spawn. And just note here how I'm using game object. I've said here game object, then I'm writing this word random red spawn. Now this is a variable that I'm creating just on the fly, and it belongs only to this function. So instead of defining it up here, it's not up here, we never typed it out, but we can actually create variables that are just local to that function by just typing them here. Like you just type, like for example, transform, whatever, and then what it's equal to. So game object random red spawn is red spawn points. Now we'll pick a random one. So we put a square bracket. This red spawn points is an array. We can select an element in that array. So, you know, the first piece of data, the second or the third or whatever, how many they are in there. So we're going to use random.range. So random.range, and what is the range? It's from the first element, which is 0. The first element is always 0, to whatever the length of this array is. So red spawn points dot length, and close that curly bracket and close the square bracket. Okay, so all we've done there is to say pick a random spawn point from the array, and we just said there's 0 and red spawn point length dot length, because 0 is the starting element and the length would be up to the last element, so that way it will pick it won't miss any when it's randomly selecting. Alright, then after that is the bit to actually instantiate the player. So we write in there the comment instantiate the player at the randomly selected spawn point. So now we'll make use of network.instantiate and who are we instantiating? We're instantiating that red team player prefab, which will be connected to this in the inspector. So that was red team player. Next, where will we instantiate them? We'll instantiate them at that location, so the random red spawns location. So random red spawn dot transform dot position. And what will the rotation be? So I'll go to the next line. It'll be the rotation of that randomly selected spawn point. So random red spawn dot transform dot rotation. And which group does this network object belong to? So we had there red team group, and we can close that. So our instantiate will work now. We've finished our function, but we also need to make use of the function. So when the player clicks on a button, that would be the sensible place to execute the spawn red team player function. So just after just connect to server is equal to false, we'll type there spawn red team player. There you can see the function, and opening closing curly bracket, and that's it. So now we'll just copy paste code for the blue team player. I'll save it so far. So copy all of the void spawn red team player and paste it below, and change the word red wherever to blue. So spawn blue team player, find all blue spawn points, and place a reference to them in the array blue spawn points. And I'll change this to blue spawn points is equal to game object dot find find game objects with tag spawn blue team, and randomly select one of those spawn points. Yes, game object random blue spawn. So we'll create a new variable here, random blue spawn, not red spawn points. I'll delete that, leave a little space, and write blue spawn points. So that allows me to autocomplete. I'll press delete to get rid of the gap. And once again here, I'll do the same thing. Let's press a space, blue spawn points. And that line is sorted. Yes, it is. Next, instantiate the player at the randomly selected spawn point. Okay, network.instantiate. No, we'll be spawning the blue team player now. And what's the position? It's random blue spawn. Same for the rotation, delete that. Random blue spawn. And the group is blue team group. Alright, so we've just gone ahead, made the blue team player, well, the spawn blue team player function. Just take one last look at it, make sure that we've changed all the red references. And it looks right. So now the next thing is just like up here for the red button. We should also, once again, when the player clicks the blue team button, join blue team button, they should be spawned as well, a blue team player. So spawn blue team player, opening closing brackets, and that's it. And we'll save the script. How does it look? Yes, it's looking pretty good. So we can jump back to Unity, configure it. So we have here empty slots for our prefabs. So player red prefab, I'll drag into the red team player, and player blue, I'll do the same thing, blue team player, and save the scene. And we can probably build and run. So file, build and run. I'll hit play. I'll set up a server. Connect to a server. Now let's pick one. Join red team. And yes, we're in. You can see that if you look here, that the player back in the server, you can see that the player has been instantiated. Now though, just watch though. Even though I'm moving around in the player's game, you'll notice that there's no movement in the server because we haven't configured our player for multiplayer yet. There's no way for it to tell the server. So as I'm moving in my game, there's no way at the moment that I'm telling the server that, you know, I've moved to such and such location, so update my position across the network. Nothing like that has been done. And that's what we're going to do in our next objective. But before we do that, let me just check that I can connect as a blue team. Let's just check everything is working. So join blue team. Alright, I'm in. But what about in the server? So we see here player blue clone, sorry. And you can see that we have instantiated as a blue player. So I'll just stop playing now. And I'll close down our game there. And we can move on to the next objective where we configure our player for multiplayer. We've moved on to our second objective, which is to reconfigure our player for multiplayer. To do this, we're going to edit 5 scripts and create another script called the movement update script. Now what we'll be adding to our scripts is the statement, a check. If network view.isMine is true, then the script would be enabled. If it isn't, then the script is disabled. So by doing this, only the scripts on our player, which we own in our game instance, only those scripts will run. So when other players connect to the game and they're in our game, then their scripts, they don't run. So for example, their Fire Blaster script, which allows us to fire projectiles, when we press our left mouse click, the Fire Blaster script on all the other players will be disabled, so we won't be firing their weapon. Otherwise, if we didn't have the check and if we pressed our left mouse click button, then everybody's Fire Blaster script would run and everybody would fire a projectile, which is wrong. So our first step would be to edit the character motor script. I'll open up the character motor script. So just open it up in MonoDevelop, and we head over to it, and you'll notice that this script looks really different compared to the ones that we've been typing. It's written in JavaScript, and it's a pretty huge script as well. But we only need to make a small change to it, so just do Control F and find awake. So the awake function, there it is. This is an inbuilt function, and the awake function would run before the start function. So all we need to do is put in a simple check. If network view dot isMine is true, then we would run this code. So I'll highlight this code, and I press tab to indent it. And if you press shift tab, then you'd remove the indent. So I enclose that. And then else. So if that isn't true, then else enabled is equal to false. So this script won't run if the player doesn't belong to us, and this script is attached to the player prefabs. Then the script is just disabled and it won't execute anything. Well, in the update function. So I'll save that and move on to the next script that we need to edit, which would be the FPS input controller. So now we'll edit the FPS input controller script. Open up the FPS input controller script, go to monodevelop, and it also has an awake function, so in the awake function we'll simply write if network view dot isMine is true, then we execute that line of code. Else enabled is equal to false, and just save that. So now we move on to the next script to edit. Now we'll edit the Mouselook script. So open up the Mouselook script. Let's go over to it, and let's look for, it has a start function down here. So here we'll add, I'll just put some space there. So we'll do the same sort of thing. If network view dot, and you can see that autocomplete is totally not working. I've noticed it happens sometimes when we move from JavaScript to C#. So in this case, all we need to do, I'll just save it, just close down monodevelop and open it up again. And now it should be working. So if network view dot isMine is true, then we'll carry out this code here. I'll just indent it. Otherwise, so else enabled is equal to false. Alright, so that does that. So now we can move on to the next script, which is our own, the Fire Blaster. So now we'll edit the Fire Blaster script. Open up the Fire Blaster script, and in the start function, just add that same sort of code. If network view dot isMine is true, then we execute those two lines. Else enabled is false. And I'll just save that, but there's a little bit more that we have to do as well. We need to change the way this blaster projectile is instantiated. At the moment we're just using an ordinary instantiate command, and it's just in the update function. So what would happen is, yes, on our game, when we're playing in a multiplayer game with other players around, in our game instance, when we press the left mouse button, we would fire the blaster projectile, but for everyone else, they wouldn't see our blaster projectile in their games at all. So we need to set up an RPC that'll cause this blaster projectile to be instantiated in everyone else's game as well. So it's pretty simple. So just underneath our update function, I'll add a couple more lines there. So then I'll write there RPC in the square brackets void spawn projectile, and for this function I'll have it accept two items, a vector3, so vector3 position, and what I'm going to do in this RPC, in the RPC I'm going to instantiate the blaster projectile in there, so that way it'll get instantiated across the network. Well, that's how I'll set it up anyhow. And quaternion, so our rotation. So that's that variable. And within the RPC, I'll simply say instantiate blaster, so that's the prefab, at the position of position. So whatever the term supplied is, and the rotation, the supplied rotation. And that's it. So in our update function now, we need to change it. So what we will do is, up here in the comment, we'll change it slightly. So we'll say create the blaster projectile across the network, and leave the rest the same. I'll just put in another, bringing it down to the next line. Yeah, at the launch position and tilt angle. So I'll write a bit of new code here. Network view dot RPC. So now we're actually going to activate it. We'll make use of it. And what is this RPC? It's spawn projectile. Who should I send it to? I should send it to everybody. RPC, wrong thing I used there. RPC mode dot all, and not buffered, just all. And at what position? Because that's what, so now that we're using the RPC, it expects two items, so the parameters, and we had written in our function a position and a rotation. So I'll just cut it from here. It was launch position. So I'll just cut it there, and I'll paste it here. And next, I'll put in the quaternion, I'll put a comma, bring it down to the next line, and once again, cut all of this term out, the quaternion dot Euler. So that specified the angle at which the projectile would be oriented. So just cut it and paste it in, and put a bracket to close it off, and another one. Alright, and I'll end that line, and I'll delete the original bit that was there. We don't need that anymore. Okay, so our RPC is set up. I'll just save that. So now all that'll happen is that when the player presses their fire key, their left mouse button, then this bit of code will get executed on the player, on their player character in everyone else's game instant because of this RPC. So here we actually make use of the RPC, and here's the code within the RPC that should get executed. So our Fire Blaster script is done. Let's go to Unity and just check that there are no errors. So I'll just clear the console, and they aren't. So that means we're good to go to the next step. So our next step is to edit the camera script. So let's open up the camera script and just make a simple change in the start function. So if network view.isMine is true, then we execute these two lines of code, and the rest of the script. else enabled is false, and just save it. And so that does it for our camera script. So we're ready to actually now write the movement update script. We've progressed to our last step in Objective 2, which is to write the movement update script. Now this script is based off a script written by M2H in his tutorials, and how it works is that when the player moves or rotates, their movement update script will send off an RPC across the network telling everyone else that this is the position that we're at. And it doesn't actually tell them that we're moving. It doesn't make us move in their script, or in their game, sorry. All it does is just tell them our latest position, and our player character is just simply repositioned. So, just as an example, if this red player moves to a new position, then as they move, their movement update script sends out an RPC across the network, and that RPC comes to the copies of our player on other players' computers. So that movement update script, it receives that RPC and makes the copies of our player have an updated position and rotation. So let's move on and actually write it, and once we've written it, it should make a bit more sense. We create a new script now, so create a new C# script and name it movement update. And then open it up in MonoDevelop. And we'll write our opening comments as always. So this script is attached to each player or to the player, and it ensures that every player's position, rotation, and scale, which we'll deal with later, are kept up to date across the network. Up to date across the network. And also, I'll put in this script is, so the credit is closely based on a script written by M2H. So as usual, I'll just go and copy those variables start and end. Copy that, paste it in, and then copy the end and paste that in. So we'll type in our three variables: private, vector3, last position, private, quaternion, last rotation, and private transform, well, my transform. And I'll just save it there. And in our start function, I'll write if network view.isMine is true, then my transform is equal to transform, and I'll put here else enabled is equal to false. We will add another line of code in just a moment. We'll write an RPC. So else enabled is equal to false. So of course, if this script, well, don't run this script on the other players, only ours. So before writing the content in the update function, let's create some space there, and I'll write here the RPC. So I'll first write RPC void update movement, and what terms should it take? It should have a position and a rotation. So vector3 new position is what I'll call the variable, and quaternion new rotation. And within that RPC, I'll simply have it do transform dot position is equal to new position, and transform dot rotation is equal to new rotation. So all that's happening is when this RPC gets fired off, whatever game object this script is attached to, its position will be set to whatever this supplied new position is, and the same for its rotation. So now back in that start function, I'll add in the comment. We'll make use of this RPC straight away. Ensure that everyone sees the player at the correct location the moment they spawn. So we'll write here network view.rpc, and the name of the RPC, which is update movement, and we'll send it to everyone. No, we won't send it to everyone. We'll send it to everyone. Well, yes, everyone else except us. So RPC mode dot others buffered. So that way new players coming to the game, they will also see, well, it'll play back. So everything buffered, it'll play back in their own game. So all the old buffered stuff will get played out until the newest stuff. So by just doing it this way, .others buffered, we just make sure that in case, let's say for example, if a player spawns into the game and they don't move anywhere. So by doing this, everyone will receive the most up-to-date position, so the position at which they spawned at, and new players joining the game will see that sitting still player. They'll see them at their correct location. So that's all we're doing here. We're just making sure the player is seen at their correct location when they spawn. And on the next line, I'll supply now the position. So my transform dot position, and the rotation I'll supply is my transform dot rotation, and end that RPC. And I'll save what I've done so far. And now I'll type up the code in the update function. So in comments, if the player has moved at all, then fire off an RPC to update the player's position and rotation across the network. So to do that, we'll do a check. We have to first check whether the player has moved at all. So how we'll do that is if vector3 dot distance, and it'll need two terms, two vector3s. So my transform dot position, and compare it against last position. So if they are greater than or equal to, say, 0.1 units, then I'll close that if statement. So what we're doing here is we're just doing a check. If the distance between our current position and where we were last recorded at, and if it's greater than 0.1 or equal to that, then we need to update our position across the network. So for that if statement, we type the following code. Well, first of all, the comment. Capture the players, so we should first, before we do anything, we should capture their last position. We update the last position variable. So if this code is going to execute, then change last position to be equal to the current position. So that way when we do the check again later on, well, we're properly checking against our last position. So capture the players position before the RPC is fired off, and use this to determine if the player has moved in the if statement above. So in the next update, so the next time update runs, we'll then compare against the updated last position. So in that case, we type in last position is equal to my transform dot position. And now we'll use that RPC, and we can just copy it from the start function. It's exactly the same. So I just paste it in. So now when the player moves, as they move, this RPC will just get fired off again and again and again. And that'll keep our position up to date across the network. The thing that affects it though is ping. So obviously the higher the ping, the longer it will take for this RPC to reach all the other players. So next we'll do a check on the player's angle. So in case they're just standing still but they turn, so then we should also fire off an RPC with their updated rotation. So we do here another check. If quaternion dot angle my transform dot rotation compared against last rotation is greater than or equal to how many degrees? Say 1 degree. Then we should, and I'll just copy paste this bit right here. We should capture the player's rotation before the RPC is fired off and use this to determine if the player has moved in the if statement above. Well, I could just change moved to turned. And then I'll just set last rotation is equal to my transform dot rotation, and once again just fire off this RPC. And we can save the script now. And it looks complete to me. Let's have a run through it. Yes, it should work. So we go back to Unity now. We can't run the game just yet. Obviously we need to attach the movement update script to our players. But more than that is, we had been using, if network view dot isMine is true. Now what it requires is that there be a network view component attached to the game object which has those scripts. So we added that line of code to our character motor script, to our Mouselook script, and to our FPS well, all of these scripts actually. So if we run the game now, it would and if we spawn the character, would get error messages because it wouldn't be able to find where is this network view component. So for our blue player, so select the blue player and just attach component miscellaneous network view. Scroll down, and once again, because we're just using RPCs, we don't need any synchronization or for it to observe anything. And we also attach the component scripts movement update. So we shouldn't forget that. And more than just that, within the blue player, go to the camera head. Remember, it too has a Mouselook script, and the camera head is its own game object, so it also needs a network view. So component miscellaneous network view, and again turn off synchronization and no observation. We now do the same thing for the red player. So we go component miscellaneous network view, and once again we turn off everything, remove the observation. We attach the script component scripts movement update. Then we go to the graphics, to the camera head, and component miscellaneous network view, and do the same thing. So now let's just save everything, and we should be able to run it now. So let's go ahead and do build and run. Hit play, set up a server. I go back, let's connect. I'll join as a red team player. Alright. And the funny thing is, you'll notice I can't see the yellow cube anywhere, and you know why that is? It's because I happen to get instantiated inside it, which means our yellow cube is positioned at the same place as a spawn point. So we'll change that right afterwards. Now just have a look. So I'm moving around in my game, and you can see that it's getting updated in the server. So we know now that our movement update script is certainly working, but we really need to launch another copy of the game to see whether our system of controlling, well, you know, the if network view.isMine is properly working. So go ahead and launch another copy of the game. So I've launched here a second copy, well, it's a third including the editor. So connect to a server, connect, I'll pick the blue team, and yes, you can see that if I just move it a bit, and I move close to the, oh whoops, I'm using the red player right now, return to game, so let's go close to that red player, and you can see that as I move or fire my weapon, we're not affecting the other player at all. So our script is working as we'd expect. Let me just move next to the cube right here. Let's go to the red player and see what do they see. So switch over, and yes, look, you can see that we, as a blue player, we had moved up next to the cube, and they are there. So the script is working now, and our player's movement is getting updated, and we know that we're only controlling our player, and we're not accidentally controlling the other player, which is good. So I'll just shut all this down now, and the next thing that I need to do is to unlock and lock that cursor. So you notice there that I had that disconnect window open, but I could still move, I could turn the player, I can move around and shoot, and every time you click on a button you fire a weapon as well. So we need to change that. That's what we'll do in our next objective. So I'll stop playing and move on. We've moved on to our last objective, which is to control how we lock and unlock the mouse cursor. So basically how it'll work is that we'll write a script called the cursor control, we'll attach it to our player, and this script will look at the multiplayer manager, and it'll look to see whether that show disconnect window is visible, and if it is, that means the cursor should be unlocked. If it isn't, then the cursor should be hidden. So it's quite simple. So the first thing that we need to do is to write the cursor control script. We create a new C# script now. Let's create C# script, and we'll call this one cursor control. And open it up. And once again, we'll just copy the variable start and end. Oh, but first I should type in what it is. The comments. So this script is attached to the player, and it controls whether the cursor is locked or unlocked. And the script will also have it access the multiplayer script. So I'll just write here, this script accesses the multiplayer script. And back in our multiplayer script, so while I'm at it, I'll write there in its opening comment that it is accessed by that script. So this script is accessed by the cursor control script. And this is just to help me remember how the different scripts connect to each other. Alright, so now I'll copy in the variable start and end. So just copy and paste that in. I'll do the same thing for the other one. And let's type out our variables, so just 2 of them. So private game object multiplayer manager and private multiplayer script multi-script. So I'll just save that. And what we're going to do is that we're going to access the multiplayer manager. We're going to find it. Then we're going to access the multiplayer script on that game object. And within that script, we're going to find out whether that disconnect window is visible. So we'll look for the condition of this variable. Show disconnect window. Oh, and I've just noticed something. You'll see here that it's a private variable. Now, by it being private, it means that we won't be able to see it from the other script. So I'll set it to public right now. And save that. And head back to our cursor control script. So in our start function, we'll put there if network view dot isMine is true, then what we'll do is we'll find the multiplayer manager. So multiplayer manager, this is our variable, is game object dot find the actual, so find the multiplayer manager. So this variable of ours, multiplayer manager here, is a reference for that. So once we have that, now we access it. So multi-script, or we access the script on it. So multi-script is multiplayer manager dot get component, and then put the less than and greater than or sign, and just put a opening closing bracket, close off that line. Now within the less than and greater than sign, we type the name of the script that we're accessing, and that is the multiplayer script. So that's how that looks. This is how you access a script on another game object, and we will be doing that a lot in this series. Now after this, we put in else enabled is equal to false, and save that. So within update now, I'll put there if multi-script dot show disconnect window. So you remember we just set that to public right now. If we hadn't, we wouldn't have been able to find it. Dot show disconnect window is equal to false. Then lock the cursor. Then screen dot lock cursor is equal to true. Now if multi-script dot show disconnect window is equal to true, then screen dot lock cursor is equal to false, and we can save that. So we can now go to Unity and attach this script to both players. So our player blue, I'll add their component, scripts, cursor control, and the same for our player red, so you can see it added there. For our player red, component, scripts, cursor control. And then I'll do file, build and run. Hit play, set up a server. I'll connect to the server. And now what we need to do, as you can see that the cursor is gone. And if I press escape, then the cursor is unlocked and visible. So if I click return to game, it becomes locked and it disappears. In the video though, I actually have to just edit the cursor out. In the video, in the screen capturing, it actually appears there in the center of the screen, so I just edited it out of the video. But in your actual game, when you build it, when you lock the cursor will just disappear, and when you unlock it, it'll reappear. So when we press escape, it'll get unlocked and we can actually use the cursor. Now we can't just stop there, because you can notice that while we have the menu open, we can still move around, we can fire a weapon, we can, as we try and move to a button, we start moving our camera, and that's just no good. What we need to do now is to lock the controls when the player has this menu open, or any menu in the future. So let's just close this down and we'll move on. That's our next step. So we're now on our second step, which is to stop the control inputs when the cursor is not locked. The first script we'll edit is the Fire Blaster script, so I'll go over to it, and all I'll do is in this line here where the player presses their left click button, I'll add another condition. So I'll put here and screen dot lock cursor is true, and save that. So now the player will only be able to fire their weapon when there's the three conditions. The first one is the left mouse button has been pressed. The second one is enough time has elapsed since the last projectile was fired, and the last is that the mouse cursor is locked. So the next script to edit is the FPS input controller, and in this we'll place everything in the update function within if screen.lockCursor is true. So we'll put here if screen.lockCursor is true, then we would run all of this code, and I'll put everything here. I'll just tab it all and enclose it. Alright, and I'll save that. So now we can't move. We won't, when we press our WASD keys, if the cursor is unlocked, then nothing will happen. We won't be able to move anywhere. So finally we'll go to the Mouselook script, which we have over here, and change this one as well. So in update, we'll enclose it as well. If screen.lockCursor is true, then the player can, rotate their camera head or their cells. And of course I need the parentheses. And that's it. So now this script will not operate if the cursor is unlocked. So now we can go and check that out in Unity. Do a file, build and run. Hit play. Set up a server and connect to that server. So I'll connect as a red team player, and yes, of course our cursor is locked. Now if I press escape, now you can see as I move the cursor around, we're not rotating. If I press left mouse click button, we're not firing, and if I press WASD or the jump button, nothing is happening, and that's exactly what we want. But there is one problem, and I'll show you what that is. So let me start moving towards the block, and then I hit escape. Now even though we're not supposed to be moving, we're still sliding on and on and on and on. So we just have to make another change, and that's our last step for this video. So I'll just disconnect, exit. Oh, and before that, I should move that cube out of the way. I forgot to do that. So I'll just change it to 20. And now we'll move on to our last step. So we're on to our last step now, which is to prevent unwanted movement by editing the FPS input controller. So when our mouse cursor is unlocked, then we should not move at all. So we just go to our FPS input controller script, and in it, within the update function, we'll add some new code here. So let's create some space there, and I'll just add a new if statement. So I'll put here, if screen dot lock cursor is false, then we're going to set this direction vector here. We'll set direction vector, no, not direction length, so direction vector is equal to a new vector 3 and it'll be just a vector full of zeros. 0, 0, 0, and close that. And then next, we'll copy paste this bit here, motor.input move direction is equal to transform.rotation times direction vector. So I'll just copy that. And what this will do is, when the cursor is unlocked, this direction vector is going to be set to a 0, all zeros, and when that is the case, then the motor script will simply try and apply movement in that direction, but because it's just all zeros, there'll be no movement at all. So that's all that we're doing there. So you can see here it's saying apply the direction to the character motor. That's that other script, the character motor script. And since we put all zeros, it's going to apply 0, and so there'll be no movement in that direction. So I'll just save that, and we can jump over to Unity and test that out. So I'll save the scene and file, build and run. I'll hit play. I'll launch a server. So I'll start my own server. Go back, connect as a player. I'll just pick blue player. Alright, so now we're moving. We press escape and we stop. And of course, when we press any of our keys, WASD, we can't do anything. So let's try that again. I'm moving backwards, I press escape and I stop. Let's move again and just hold escape down. No, nothing happens. So, I mean, well, by nothing I meant that we don't keep moving towards the cube. So it's working. So as we move to the block, and if we hit escape, then our direction vector gets set to all 0, and that means our movement in the character motor script is just set to nothing, so we don't move. So I'll just disconnect there, exit, stop playing. And we have reached the end of this video. And in this video we did a lot. We set up our whole spawn system for our players. We had changed our player prefab so that it's team now. So we have a red team and a blue team. And we had set spawn points, and then we made our player spawn at a random location, well, at a random spawn point. And then we went ahead and we edited a whole bunch of scripts on our player so that they would only work, well, they would only work on our player when we're in a network game. and then we had written the movement update script, and then we finally went ahead and we wrote the cursor control script, which allowed us to have some control over the unlocking and locking of our cursor. So we really did a lot. Thanks for watching, and in our next video we will be working on our health and damage system, and that will be a very big video.